The problem statement from GATE Physics 2013 reads as follows. What should be the clock frequency of a 6-bit A to D converter so that its maximum conversion time is 32 microseconds? This is a multiple choice question with one correct answer, and we'll find the correct answer and then tick the correct option. First, let's look at what in as far as analog to digital conversion is concerned, what do we mean by resolution? So we have an analog input and we have a digital output. We know that much. On the left side you can see the input. In the red line you have minimum and the blue is the maximum. Similarly, on the right side the red is the minimum and blue is the maximum. And let's say this voltage is Vmin to Vmax, so the difference will be Vx minus Vmin between the input voltages. Similarly, the minimum output is 0. You cannot go below 0 as far as the digital input is concerned, and the maximum input, if it's a n bit convert, if it's an n bit signal, and the maximum value that you can achieve is 2 raised to the power n minus 1. This is the maximum digital, this is the maximum in the decimal value that you can achieve, right? So the difference between them again is 2 raised to the power n minus 1. Now please note that on the left, this is just a mapping that we are doing from an input to output. We are not creating anything out of the blue. So these two things should be the same. So whatever the difference between the minimum and maximum is, should be the same in both the cases, because it's just a mapping that we are doing. Now here it's important to define what do we mean by resolution. The resolution is minimum value that can be distinctly measured. This is the definition of resolution that we see in microscopy and in fact in any other field that we see. As far as digital signals is concerned, that means the difference of 1 bit. So you can see, let's say when we are in green, right, when we are here, so let's say we have some let's say some whatever is the are the MSBs. Let's say the final two digits are 100, right? So the immediately next value has to be dash dash 101. Just the 1 bit change, that's all we should see. And if we are distinctly able to measure that, that will be the resolution. So 1 bit change in digital side is the resolution, right? And we know now that so we have, from in order to go from minimum to output, we have to take 2 raised to the power n minus 1 steps, and we all know that 2 raised to the power n minus 1 is nothing but Vx minus Vmin, which we established earlier. A simple unitary method tells us that one step will be equal to Vx minus Vmin over 2 raised to the power n minus 1, which is nothing but the resolution, because you have defined the resolution in such a manner that 1 bit change is the resolution. So this is the corresponding value in volts. We just saw in our discussion on resolution that the digital output can be represented like this. So the minimum level is 0 and the maximum level is 2 raised to the power n minus 1. Here n is equal to 6, it's given. So this will come out to be 2 raised to the power 6 minus 1, which will be 63, right? So the minimum level is 0 and the maximum level is 63. And the questions are to find the maximum conversion time. Now maximum conversion time is, let's say you are here, you are at 0, right? The maximum conversion time will happen when you will have to go all the way to 63. So you'll have to take all these steps and finally you will reach 63. So, and we'll assume that we can only jump one step at a time. Remember, we defined the resolution as one step. That was the whole idea of the resolution. It's one step. So how many steps you have to take, how many maximum steps you can take in such a setup? So maximum steps that we can take is 63, from the lower most to the highest, right? And now the question arises, how much time will it take to take each step, right? Then we'll get the maximum conversion time, right? Now depending on how A to D converter is implemented, there are different ways of doing it. The simplest A to D converter is a counter type. This is the simplest. In this counter type ADC, one step takes 1 clock cycle. This means in order to jump from 0 to 1, you will take 1 clock cycle. Similarly, to some intermediate level to this level, you will take 1 clock cycle. Similarly, to the second last level to the last level, you will again take 1 clock cycles. So what is the maximum number of, so maximum conversion time? So maximum conversion time will be nothing but maximum steps times t clock, time period of 1 clock. So this will be 63 times t clock, right? And we know that 63 times t clock has been given to us as 32 microseconds. So from this we'll get t clock equal to 32 microseconds upon 63. So this will approximately be 0.5 microseconds. And since we need the frequency, so frequency is nothing but 1 over t clock. This will come out to be 1 over 0.5 microseconds. This will be 2 megahertz. So yeah, so option B is there, which says it's 2 megahertz. So that will be our answer. The key thing is just that we have to go from minimum to maximum, and this is an assumption that we are making, that it's a counter type A to D converter. So the answer is B, 2 megahertz. Thank you for listening.